Hello everybody. Today I'm going to get you started with the 6.6 task. I have a lot of notes on these and I have them posted for you so you can use those. I have these posted also on Canvas under the Module 6 tab. So you can look at these closely. Hopefully you'll have them near you as you're looking through this. But I'm going to take you through a couple of things that I want to point out. The first thing I want to point out is in this task they're going to talk about, we're going into radians. So we always measured angles with degrees, and now we're going to talk about measuring angles with what are called radians. And so the top of this task, after you read through it, one of the things it talks about is it wants to measure the distance with the radius of a circle. And one of the things you're going to notice, and that you can do on your own if you would like, is if you took a piece of string and you measured the radius from the center to the end of this inner circle, and then you took that length of string and you wrapped it around the circle, it would go around the circle a little more than 6 times. The same would be true if you found the radius of this outer circle here. So if you took a piece of string and measured from the center to the outer circle, and then you took that string and you put it around the circle, it would cover the circle a little over 6 times. Okay, so mathematically what this means is, if I take the circumference of any circle and divide it by its radius, you're always going to get 2 pi, and that's the number of times the radius will fit around a circle. That's why these are called radians. So remember, the formula for the circumference of a circle is 2 times pi times the radius. If I divide both sides by r, I get c over r, circumference over the radius, is equal to 2 pi. So no matter how big or small your circle is, when you take the circumference and divide it by the radius, you're always going to get this constant number, 2 pi. Remember, pi stands for 3.14 and so on. So if you type that in your calculator, 2 pi, you get 6 point something. So it's showing you that that's always going to be the same. So what that means is, if I were started a circle and I go all the way around, we know that would be 360 degrees. So in radians, it would be a measure of 2 pi. So 360 degrees would be the same in radians as 2 pi. That's what that's talking about. Okay, so the next part of this task that I want to show you has to do with this circle. So this problem here is going to describe, you can read through it. But basically what it's saying is, let's take this inner circle first. And what they want to do with this inner circle is they want to place 12 stakes. They want to mark 12 points around that circle. So first of all, if you recall what we did at the beginning of this module, I'm going to see how many degrees are going to separate each one of them. So 360 degrees divided by 12 stakes, because that's how many or markings that I want to make, that will give me 30 degrees. So we're going to put a stake every 30 degrees. Now you have to read through the task to understand what I mean by a stake. But it's going to be every 30 degrees. And so what they did was, and I'm going to start with this inner circle here, okay, which is why at the top I have inner circle, so you can understand it when you read through your notes. But what I did was I said, okay, so let's just go 30 degrees. Now I don't want you to look at this blue one, that's for our next one, that blue triangle. I want you to look at this one that is in pencil here, okay? So this triangle here. So what I did was I said, okay, let's say this from here to here is 30 degrees. That's why I marked it. So if this is 30 degrees and I drew this straight down, I know this is 90. That leaves 60 degrees for this. So what I've created is that 30, 60, 90 right triangle. Okay. So again, I give you some reminders up here. The radius is 12. They told us that. The radius of this inner circle is 12. This is a 30, 60, 90 triangle. Remember your sides. Across from the 30 is x, across from the 60 is x root 3, and across from 90 is 2x. So for the second stake, because the first stake was right here, so for the second stake, because I'm inside on this inner circle, so for the second stake, I have to look at this triangle here. The radius is 12. Well, if the radius is 12, then half of that is 6. Because remember, across from the hypotenuse, across from 90 is 2x. So 12 is equal to 2x. That means x is equal to 6. So across from 30 degrees, that's why I put the 6 here with a circle around it. So the length of this from here to here is 6. And then across from your 60 is x root 3. Well, if x is 6, then this is 6 root 3. This is across from 60 degrees. So what I did is I found my first set of coordinates. It's when you read problem 3, it's what they asked you to do. So for the second stake, these are the coordinates of that point, where this point right here would be, is going to be, the x coordinate is 6 root 3, because that's what this is, and then your y coordinate is 6. Now when you do this, you're going to want to fill it in on this third page here. This is the chart you're going to fill in. So remember, stake 1 they did for us. It was a 12, 0. Stake 2 is, I put here for myself to remind myself it's 30 degrees. And then I found those coordinates, 6 root 3, comma 6. Okay, the second thing they want you to find is the arc length. They want you to find the length of this arc. Sorry, I keep going to the outer circle. On this inner circle, from here all the way to here, they want to know what that arc length is. So if you recall, it's one of the last things we did before we left. Arc length, there was a formula, and this is on your second sheet here. I wrote it down. S represents arc length, is equal to the circumference of the circle times the angle measure over 360 degrees. Okay, that's theta. And then this is your circumference, 2 times pi times the radius. Okay, so what I did, I showed you I took the circumference is 2 times pi times the radius is 12 times 30 degrees, that's what we're dealing with, over 360 degrees. I reduced this to 1/12. I multiplied 2 times 12 and got 24 pi, and then I simplified this to 2 pi. So the arc length is 2 pi, and there's a place right here where it says distance from 12, 0 along the circular path. I wrote on there arc length. Put that for yourself. So I wrote it in. I found it to be 2 pi. And then the third column says, what's the ratio of the arc length to the radius? That's just a fraction. So the arc length, we said, was 2 pi over, your ratio, over the radius is 12, and I reduced it, it's pi over 6. So really what that is, that's the number of radians. That's how much you're moving. Instead of saying 30 degrees, I could say I'm moving pi over 6 radians. Okay? Now, when I want to do it for the third stake, so again, I'm not on this outer circle, I'm here, this inner circle here, I had to draw a different triangle, right? So that's what you see in blue. Now, I still have this is 90 degrees here, but this time I moved 60 degrees, right? I moved 30, and then I moved another 30 to get to stake 2. So here's 60 degrees. So sometimes that can be confusing when you have one circle, one triangle on top of another. So one of the things I suggested that you do, and I wrote it down here, is to do stake 3 and so on. You're either going to erase it and redo it, or what I did is I drew the triangle just outside of it. I said, okay, this is the triangle I'm talking about. It's 60 degrees here. That's where the center of the circle is. This is 60 degrees. I know the radius is 12. I drew this right triangle. So now I can figure out my sides. So again, across from the 90 is 2x. So that means x must have been 6, because 2 times 6 would give me 12. So across from the 30, this time my 30 is up here. So down here is my 6. And then across from 60 is x root 3, so it's 6 root 3. So this time my coordinates for stake 3 are going to be 6, that's your x coordinate, comma 6 root 3. So on the stake 3, I put 60 degrees return, and it would be 6, comma 6 root 3. And then to find the arc length, I'm going to take the circumference, which is 2 times pi times 12. We're on the same circle, so that's always going to be the same, 24 pi. But this time it's 60 degrees over 360 degrees. Simplifies to 1/6, then I end up with 4 pi. So my arc length now is 4 pi. When I show the ratio, the arc length, which is 4 pi, over the radius, which is 12, reduces to pi over 3. Okay, so then when I get to stake 4, now remember, stake 4 is going to be 90 degrees, because we went 30, 60, well, here's 90. So stake 4 is going to be right here. Well, that's right on what my radius is, correct? So that's why for stake 4, which is 90 degrees, the coordinates would be 0, 12, because I'm right on the axis there. And then the arc length, to find that arc length, I'm going to do my circumference, which is 24 pi. Remember, it's the same thing, but this time it's 90 over 360, which reduces to 1/4, and that gives me 6 pi. So that's what I wrote in here. And then I took 6 pi, the arc length, over the radius, and I reduced it to pi over 2. Okay, so what you're going to do now, that's kind of the hard part. Now I'm going to use symmetry, just like we did at the beginning of this module. I'm going to use symmetry for this. So stake 5 is going to be symmetrical, it's the same thing, as my stake 3, right? So stake 5 and stake 3 are going to be the same. The only difference is, and I wrote it down here for you, the only difference is that now you're in quadrant 2. So now that I'm in quadrant 2, my x and my y are going to switch. So remember, in stake 3, I had 6, 6 for 3. But now because I'm in quadrant 2, my x becomes negative. So here's stake 5. It's going to be a negative 6, but my y value still stays the same. Okay? And then, again, let's find the arc length. Now, to find that arc length, remember, it's not going to be the same because now you have to 30 to 90, which gives you 120. So now it's 120 degrees over 360, which reduces to 1/3. So my arc length is 8 pi. So that's what you see for stake 5. The arc length is 8 pi. And so now my ratio is 8 pi over 12, which reduces to 2 pi over 3. Okay, now you're going to keep moving through that, and I wrote some notes on here to kind of help you through what it's symmetrical to, and hopefully you'll remember what we did at the beginning of this module to kind of see what I mean by which triangles are going to be similar. And then it's just a matter of figuring out what your sign is. Now, this whole section here is for that inner circle, and then the outer circle is this one, where now my radius is 18 instead of 12. So I kind of started you off over here. Here's your outer circle, and I kind of just started drawing a triangle. I did it for stake 2 and stake 3 to kind of help you out, and then you can use symmetry for the rest. So I want you to work on that to see how you do with it, and then, compare it to what I have here to see how you do with that, okay? That's basically what that task is to get used to it. Now, a couple of things I made notes on the bottom here are, as you're filling this out, you're not even going to have to do everything, because if you notice symmetry, you don't have to keep reinventing it. Just pay attention to the quadrant you're in. And notice what happens with the arc length. Okay, notice the pattern that's happening there. And then I also want you to notice what's happening with the ratio of the arc length to the radius. Now, once you do the 12-meter circle, notice it with the 18-meter circle and see some things that are similar, that are the same, and some things that are different, okay? You're going to notice some patterns there that should help you. When you're done with that task and you go through it, what I'd like you to do then, you're going to do the readies and the goes, which I mentioned. And your readies, and I crossed a few things out. So you're just going to find the arc length. So they have the formula written for you there, but remember, diameter is 2 times the radius, so that's the same thing. So I kind of gave you some notes there. And then really important is the last, the goes, skip the sets. The goes are going to talk about how we can convert from degrees into radians and from radians into degrees. Now it shows you exactly, and it talks you through how to do it right up here. So this is what I want you to kind of pay attention to, and then look at my examples of how I worked it. Use it for the first few, and then make sure you try to do it on your own. If you copy it all, you're going to make it harder on yourself. So I need you to kind of really pay attention to how they're asking you to convert it. If you're given degrees and you have to convert it to radians, you are simply going to multiply by pi over 180 degrees. And then if you're given radians are always given in terms of pi, then you're going to multiply by 180 degrees over pi. And you'll see that when they cancel y, you end up with degrees, or y, you end up with radians, where you have pi in your answer. So give that a try. That's going to be your homework for this week. I'm going to set up an evening review to kind of help, answer any questions you might have. If you can't wait for it, or you can't make it to that one, just email me. I can try to Zoom with you and talk you through any one of these problems that you might need help with. So let me know, and I hope this helps. I know it seems a little confusing now, but if you take the time to use this video, but also go through the notes carefully, I think you'll be okay. And maybe you'll have a few questions, and just write them down so you don't forget to ask about them. Okay? All right. Well, good luck, and we'll talk to you soon.